Okay, so welcome back. And now that I've provided you a little history lesson about the world of atomic absorption and atomic emission, we now need to start discussing a little bit of the theory that's associated with why these things work. Okay, so in a general chemistry class, this is typically what you learn. We have an element, and this element has some electrons that are located in maybe an outer ring somewhere. So let's say there's two electrons here, and there's an electron here, and that's all that this one's got. All right. We call this the Bohr diagram. And what happens is that these electrons, like most of the time, everything's due to electrons, have some wiggle room and some movement that goes on. So in a general chemistry course, what you will talk about and discuss is that this atom will gain energy. And a lot of times your instructor will put a little H and a V up here at the top to talk about energy. Well, that H and that V are very important because one stands for a constant number and the other one stands for frequency. And those two numbers really kind of wrap themselves up into a form of energy that we call light. So we give this atom light energy. And these electrons are like little kids with chocolate bars. They like to take the electron, and the electron likes to eat the energy up, gobble it up. And then when they do, like kids high on chocolate, they start getting hyper and they start moving around more. And it's not uncommon for an electron to kind of jump up and go to the next energy level, is what we call that. And we have a electron that is moved from a ground state that we would say here. This is its original position, so we call this the ground state. And this is the region that it's promoted to, so we call this the excited state. So we have these electrons and they will gobble the energy up and they will start jumping energy levels and they will go from ground state to excited state. That process is called absorption. It's absorbing the light that's given to the atom. So this is the process of AA. And this is how the AA instrument works in regards to the element. There's 65, 70 metals that can be detected using the AA instrument. And the reason is because all of these elements have a different Bohr diagram. They have a different number of electrons in the energy level. That's what we mean by that. So no two elements are going to be the same. Go figure. All right, well, like kids on chocolate, the electrons will have to settle back down. There's going to be a sugar crash involved. And these kids are basically going to pass out in the front yard. Or they'll come home and they pass out in front of the TV or in front of the PlayStation or Xbox. And when these electrons crash and when they settle back down, well, it goes from the excited state back to the ground state. But in order to do that, the electron has to give off a certain amount of energy. It's actually the same amount of energy that it took in, the same amount of energy it gives off, right? Law of the conservation of energy says that what you start with, you have to end up with. And what we start with here, we end up with here. This process is the atomic emission part. The atom is emitting energy, and that emission we can record and log in the AE field. So that's how those two concepts are related. In the first part, an element gets presented to a light bulb. This light basically gets sucked up in the atom. The electrons begin to jump to go to excited states, and that absorption of the light is called atomic absorption. Sooner or later, though, those electrons have to settle back down and they crash. And when they do that, they give off that same amount of energy. And when they give off that amount of energy, that's what we call atomic emission, because it's emitting light. So again, emission and absorption are two pieces of the same puzzle. Here up at the top is what we would call the continuous spectrum, Roy G. Biv, all the way across. An element could be heated and give light off, and that given off energy is what we call atomic emission. And in this example, this is the energy that the atom is giving off. Those couple of wavelengths right there. However, cup half full, cup half empty. If the atom can emit light, the atom can absorb light. So we can give it a light bulb, and what we would discover is that that atom would suck up the light, absorb the light in those areas, there, 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 and there, and that perfectly corresponds to the areas that it gives off. Again, law of conservation of energy. What gets absorbed by the element has to get emitted by the element. And that's a perfect comparison between the two. All right, so in the next video, we'll talk about more specifics about the instrument and more specifics about some of the theory that's going to make this work.